Now that we have this basic scatter plot with React and D3, let's add some axes and axis labels so that it becomes an actual readable data visualization. I'll start by forking this. I'll call it scatterplot with React and D3. Now, let's see what the AI could do. Add margins. Okay, this looks good. The first step towards adding axes and axis labels is to add margins. That's space around the visualization area. And let's see how the AI did it. Now we have margin as an object. This is the so-called margin convention. This is how margins are conventionally represented in D3 examples. So it's an object that has top, right, bottom, and left. And these are pixel values. So the 20 here is how far away from the top edge is the edge of the inner rectangle. And that's where the center point of this dot is. So this space is 20 pixels. And then it just adds that same 20 pixels all around, which we can tweak later. And then we pass it in to our viz function as another option. Looks good. And then let's see the changes to viz.js. We destructure the margin and then modify the range of the scales. So instead of going from 0 to width, now it goes from margin.left to width minus margin.right. That looks good to me. And then there's a similar change for the Y scale. Okay, that's how we can add a margin. Next, let's add axes. It's somehow wanting to change the color. Let me just say undo. Let me start fresh. Add X and Y axes, but do not change the margin and do not change the radius and do not change the color. Okay, that looks good. Now, this is a ridiculous pattern, and I'm going to hand edit this and explain what's going on along the way. I see this in a lot of D3 code where the author doesn't necessarily know about the general update pattern, the data join, the idempotent rendering idea. So we should never do this. svg.selectAll*.remove. No, we don't want to remove everything. Let's quickly take a look at the diff and then dive in to the manual editing. So we just add some imports and then we create this x-axis generator by saying axis bottom, passing in the x scale. That's how you instantiate the axis generator. This doesn't render the axis. It just instantiates what I like to call as the axis generator, which is a thing that you can call that will render the axis. And then this is non-idempotent rendering right here. It's selection.append_g. That will append a new group element every time. But basically it works. And what it does is say append G, that appends a group element in SVG, which is kind of a container element. And then we set the transform to be translate 0 in the x direction, and then in the y direction, meaning down, height minus margin.bottom. That's correct. That puts this axis at the bottom here. And then we use .call, which is a function on D3 selections that will invoke a function passing in the selection as the first argument. And so this is what renders the x-axis. And it's a similar pattern for the y-axis. So let's fix the pattern though, so we use idempotent rendering. Don't use this pattern. And then I'll paste it here, and I'll say, instead use idempotent rendering with two different classes, x-axis and y-axis, creating each G element with the .data passing a single element array with null pattern. Let's see if it can do this. Send. Okay, so it removed this pattern. Good so far. And then for the x-axis, and it even updated the comment. I love this. AI is so cool. Add or update the x-axis. That's correct. That select all dot x dash axis dot data null dot join g dot class x dash axis. This is absolutely perfect. Now the reason why we need to put classes is because if we were to say select all g here, the second time it renders, it would pick up on the group element for the y-axis when it's trying to render the x-axis. And so in order to disambiguate between these two different group elements, we use classes. This is a pretty common pattern. Okay, so far so good. Now, the only thing remaining is to, hand tweak it, but also add axis labels for x and y. Let's see how it does with this one. Okay, that's perfect. One shot. Okay, so from the app, when we call the viz function, we add these two additional options, x label and y label. So far, so good. It did adjust the margin. And then here's the code for the x and y axis labels. Again, we use the same pattern. Okay, so AI is good at figuring out what pattern we're using and using it. And then we have these classes x-label and y-label. And then we use this idempotent rendering pattern. And they appear here. Sepal width, sepal length. Digging in a little bit to the detail for the x-axis label, which is this one here on the bottom, it's centered with respect to the entire container. We could center it within the inner rectangle, but it's whatever. I mean, this is pretty good, pretty clean. I don't like this hard-coded constant, but we'll address that later. It's setting the y position to height -10. So y as height would put it at the bottom and actually below the bottom, so we wouldn't be able to see it. And then -10 means up 10 from the bottom. And then text anchor middle sets it so that it is centered on that XY point. And then we're just setting the font size as an attribute, which you can do in SVG. We could also do it as a style, an inline style or a style from a CSS file, either way. But this is pretty good. And then .text is X label or empty string. So this just, it's not really necessary, but in case we don't pass in any value for X label, it will, if this evaluates to falsy, which is undefined, it will fall back to empty string. That's fine. And then the same thing for the y-axis label, but this time we are rotating the text 90 degrees. So that's this here. So yeah, transform, rotate -90. Awesome. See, the transform attribute actually accepts a string in a domain-specific language for transforms. So we saw translate, which just moves things around, but you can also rotate, which rotates things. And then the X and Y are always really tricky when you have a rotate in play, and I always get super confused. But this basically looks right, where X is minus height over 2. Super confusing, but basically it works. The last thing I want to do to clean this up is get rid of these hard-coded constants. There's 40 and 10. So let me say, refactor the hard-coded constants of 40 and 10 so that they are new options passed into the viz function called x label offset and y label offset. Let's see what it does there. Okay, that's perfect. That is absolutely perfect. So now these are additional tweakables that we can tweak all in one place. So instead of being hard-coded, they are now no longer hard-coded. Oh, they have defaults even. Nice touch. Okay, so it's basically looking pretty good. The font is just a little too small, and it's using the serif font. So as a last final thing, let me say, make the font bigger and use sans serif. Let me just fix that typo, sans serif, send. Okay, so it just changed the size and set the font family to be sans serif. And if you wanted to customize this, you could pull in fonts from Google Fonts. They work very well, but I think I'll just keep it here for now. Okay, that's how you create a scatter plot with Reaction D3, including margins, axes, and axis labels. Now let me do one final run through where we review the whole code. In app.js, we have a couple new things. We have this margin represented here as an object, and that margin gets passed in to the viz function. And because margin is defined here outside of everything as a constant, we don't need to add it as a dependency here. But if you were to refactor this in the future and margin could be dynamic, you would want to add it as a dependency. We also have these new options: xlabel, sepal length, which goes here, ylabel, sepal width, which goes over here, and then xlabel offset. And if we tweak this, we can see that it just moves that label up and down, and similar for ylabel offset. And then over in the viz function definition, we are destructuring these new options here, giving these offsets defaults. And then the range of the scales is different than it was. Now the range takes into account the margin. And then here, this logic represents rendering of the x-axis in an idempotent way, meaning we're using classes to disambiguate between the two different group elements, and we're using this .data null pattern. This transform translate moves it down to the bottom, and just let me show you real quick. Without this, it appears at the very tippy top here, which is not what we want. And then same story for the y-axis, but instead of axis bottom, it's axis left. And we are transforming by translate margin left. And again, if we don't do this, you can see it's right up against the edge, which is not what we want. And then the trickiest part of all this could be the axis labels. So here we're rendering the x-axis label, and here we're rendering the y-axis label. And then finally we're rendering our marks. Now I kind of don't like how big this file is getting, so I thought this would just be a rundown review, but actually to really wrap this up, let's refactor the axis rendering logic into a separate module, and also refactor the axis label rendering into a different module. Okay, let's see what this does. So now viz imports render axis and render axis labels. Nice. So yeah, now the viz function is smaller. Oh, but it's defining the scales inside of render axis. No, I don't like that. So let me say undo. And let me rephrase this prompt. Refactor the axis and axis label rendering logic to separate modules, but keep it so that the scales are defined in the viz function. Let's see how this looks in viz.js. Okay, good. The scales are the same, but now render axis is a separate function, and render axis labels is a separate function. Yeah, this is good. I just prefer to have smaller files. So, okay, that's all for Scatterplot with React D3.